It would be a great help in such cases if we could sort letters into folders automatically, or scientifically said, cluster them. Clustering has been used for more than 50 years to solve such type of problems. The main idea, on which clustering algorithms are based, is the distance of elements. As a result of clustering, the nearby elements are grouped into common sets. However, what is the distance of two emails? The answer doesn't look easy. The common approach, where data are converted into numbers and regard the distance of n tuples, doesn't work in this case. Thus, it is worth to use a new method based on relation instead of distance. To demonstrate this method, we constructed a hasty fuzzy relation which could be improved further for real-life usage. Calculating these values for each pair of emails and representing the values in matrix gives this picture. Each line and each column of the matrix corresponds to one email. The darkness of one pixel of this matrix represents the value of similarity of the emails corresponding to the row and the column of the pixel. A black pixel denotes total similarity, and a white pixel denotes total dissimilarity according to our relation. The figure is pretty light, so the values of similarity are rather low. In case of emails, it was easy to create this fuzzy relation, which compares any two letters. In other cases, it is possible that a human activity needs, and it can be expected from a user to decide about the similarity of any two elements. At common law, legal systems rely on precedents that are judicial decisions on similar cases. Hence, both of the opposing parties cite some cases which are similar to the actual one by their opinion, and the jury decides on the similarity. Hopefully, they do not need to take into account all the legal cases, just the cited ones. Therefore, the similarity of legal cases is not a total relation, but a partial one. This is not a problem, although the applied clustering algorithm was developed for total relations, but works for partial ones too. To apply the clustering algorithm, we need to defuzzificate the fuzzy relations. This needs two parameters which defines three sections. If the value of the similarity relation is less than the lower parameter, we dismiss the relation, while if it's greater than the upper parameter, we accept it. Otherwise, the answer is simply I don't know. Let's see how this diffuzzification works in case of a monochrome photograph. To avoid choosing parameters randomly, let's see some statistics about values of similarity. This is the histogram of the original picture before. And this one is the histogram of our fuzzy relation of emails. It contains some outstanding values. We choose our parameters based on these. Let's see some defuzzificated relations. If both parameters are before the second peak, we'll have many similar letters. If the upper parameter is after the second peak, the number of similar emails lessens. If the upper parameter is around the third peak, there are still similar letters. If the upper parameter is after the third peak, the similar emails become very rare. A relation like this is the input of clustering, and the partition of emails is its output. This picture shows a relation. The solid lines denote the similarity and the dashed lines the dissimilarity. And this is a partition of the objects. We rate partitions by evaluating its correspondence to the relation. We are interested in how many similar pairs are in different groups and how many different pairs are in the same group. We denoted these pairs with red lines. The less such pair exist, the better the partition is. We search for the best partition, which contains the least contested cases. It is obvious that it's impossible to avoid these odds, but our task is to keep it at the minimum. However, it can easily occur that there are more than one best partitions. This means that we have several clusterings which are equally good. There is no reason to choose one of them and omit the others. The more partitions we have, the more information is presented. As these partitions differ, there are members which are sometimes in the same, sometimes in different sets. Based on some relations, these objects could separate, but we cannot say that they do not belong to each other, as there exists an optimal partition which connects them. Of course, there could be members which are in the same sets in all of best partitions. Those cannot be separated based on the relation, thus they are considered inseparable. We need to provide objects similar to a concrete one. First, we consider the intersection of its clusters in the best partitions, meaning its inseparable objects. It can be called the lower approximation of the object. The union of the lower approximation of all objects is a base set depends on strict peculiarity, if we intend to use the terminology of rough sets. We can also take the union of clusters from the best partitions containing a concrete object and should call this as its upper approximation. This kind of similarity is only a weak peculiarity. Next, we could treat the rough clustering that assign a lower and upper approximation of objects to a relation. Next figures show the lower and upper approximations of the object according to different relations. The rows and columns of the matrix correspond to one object again, but their ordering is different. We reordered them so the objects of the members of base set follow each other. Let's see the partitions of the emails according to different relations. If the upper parameter is just above the second peak of the histogram, then most of the objects are members of the base set, although the level of the similarity is low. The upper parameter is just above the third peak of the histogram, then the biggest member of the base set gets smaller. Increasing the upper parameter, the size of the members of the base set decreases even more. Let's see how these results can be used. If the region of the values of similarity satisfy the relation is narrow, then we get small clusters. Then we can tag all emails with the labels of males in their lower approximation, because they are very similar. However, if the region where the relation holds and where it is undefined is wide, the method can be used to discover emails which can be similar to the selected one. Using these two kinds of relation iteratively, the secretary can easily solve the labeling of emails concerning the subproject because this tags objects of some member of the base set of the narrower relation. Naturally, the rough clustering can be used to organize our inbox as well. In this case, it tags or sorts our incoming letters into folders. Moreover, this method, unlike other clustering algorithms, could indicate that the folders should be modified. 2 folders should be merged. 1 should be broken into subfolders. As seen, this method has some advantage, but it also has some handicaps. The boss of the employee can easily verify how they work. The transitive closure of the upper approximations of the letters of the business partners can be tagged as work-related email, while the others are the private emails. The rate of the number of such letters can be a warning sign for the boss without even having to disturb the secret of private letters. On the picture, we mark the mails of the business partners in the diagonal with green. If we calculate the transitive closure, we get all work-related mails. In this case, from 48 mails, 15 was private. A more sophisticated analysis could be done with this kind of clustering. If a user is involved in a project, we can regard their mails of some period. We mark these letters again with green in the diagonal. This will be the subset of all letters of the employee. The boss may be interested in the upper approximations of the user's emails of this period. If this contains some member of the base set are related to the project, like one mark with red on the picture, the employee has done their job. Or more precisely, they did something on the project. If the lower approximation contains such a member of a base set, marked again with red, then they worked on a subproject which belongs to this member during that period only. Do you have a relation to test? You can try it now! Our software is available here.